Hey, I'm Courtney Waterman, your tutor. Lover of anime, manga, and math. And you just tuned into another session of Tutor Me Sempai. Welcome back, everyone. Today we're jumping into a 10th grade topic, polynomial long division. Now, if you're new to my channel, I'll be putting time codes in for this video in the description box below, so use that to skip ahead to whatever part of the video you think is most interesting. As always, if you have any questions about what we see today, or even your own homework, you can always put in the comment box below, or visit my Facebook page at Tutor Me Sempai and tell me all about it there. At the end of this video, I'll be linking my 10th grade playlist in which I cover a lot more topics. So if you're interested in that, make sure you stay tuned. This video is going to have 3 parts, so leave a like, smash subscribe, and let's get started. Now, polynomial long division is going to be very similar to regular long division in both look and feel. As you see, you set them up the same way, and in fact, you're going to be using a lot of the same steps you would do in regular long division to tackle polynomial long division. They even share some similarities as to why we do division in the first place. In regular long division, one reason we do it is to see if our divisor is going to be a factor of our dividend. In this case, our 5, is it a factor of 10? In polynomial long division, it's going to be the same exact thing. We would do it to see if the divisor is a factor of the dividend. That's not the only reason, but that is one reason. And just like regular long division, if there was no remainder, that meant that your divisor was indeed a factor of your dividend. The same thing is going to be true for polynomial long division. If there's no remainder, that means your divisor is in fact a factor of the dividend. And in both cases, if it's not a factor, there will be a remainder. So today we're going to do 2 examples, one of which doesn't have a remainder, and another one that does have a remainder, so you know how to write both type of answers. So for our first example, we have 2x cubed plus 6x plus 152 divided by x plus 4. And we're going to set this up in polynomial long division style. So we're going to take our divisor, which is x plus 4, and we're going to put it on the outside. So it's going to be x plus 4. Let me put our little house here. And then we're going to have 2x cubed. And until you get more familiar with this, I recommend putting some placeholders so you don't get confused when we start doing our math. So we notice that we don't have an x squared here, but we're going to put a placeholder. So it's 0x squared. This is not necessary, but until you get more familiar, this may be helpful. Plus 6x plus 152. So you may be missing more than one power of x here, or power of whatever variable you have. I recommend putting placeholders down for each one that you are missing. That will just help to make sure that you're doing every step and you're not skipping anything. So here we're missing just one power of x, so I put that placeholder here. But like I said, you may be missing more than one. So don't just put one, put all the ones that you need, at least until you get more comfortable. Now that we set this up, we can start focusing on polynomial long division. And this right here is going to be the main character in today's story. Whatever your first value is for your divisor, in this case, it's an x. This x is going to control the show because we're always going to be referring back to this x to tell us what we're going to be doing next. And you'll see what I mean. So we look at this x and we see this very first part of the polynomial under the house. How many times does this x go into this 2x cubed? What I mean by that is, what do we multiply that x by in order to get it to be a 2x cubed? Whatever that answer is, we're going to put it right over this 2x cubed place. So once again, what are we multiplying x by to get this? Well, since we already have an x, we would need a 2x squared. If we were to multiply 2x squared times x, we should get 2x cubed. And if we do, we're going to put it right under 2x cubed. See, this should be identical. That's your first step. However, we have a plus 4 here. What do we do with that plus 4? Well, we put this up here because that's what we needed to multiply x by to give us this. Well, we're just going to carry this 4 along. Whatever this is, we're going to multiply it by the 4. So your secondary step is you take whatever you put up here and multiply it by whatever is after the x. So in this case, it's a 4, just a 4. You could have a longer divisor. You're going to take that and multiply by each and everything that comes afterwards. But in this case, we only have one thing after the x, and we're going to multiply by this 2x squared. So what do you get when you do 2x squared times 4? Well, you're going to get a positive 8x squared. Now you see why I had that placeholder here. Because if you didn't, you'll be putting it under 6x. And I don't want you to get confused when you're trying to do some more math later. This allows us to keep things consistent so you see where they're going and you don't get confused. Now that we have no more things left in our divisor to multiply by this, we can negate every sign for this bottom number. Every sign. Don't just negate the first one, negate everything. And this is similar to what we do for regular long division, except we don't have extra parts, but we do negate it. Remember, we always negate what we're subtracting. Essentially, we're going to be subtracting, but all you're doing is negating what was there. So we got to do it for here and for here. And it's so important. Negate everything. A lot of times people get tripped up because they only negate the first one. They only subtract the first one and they keep the sign of that second piece or whatever else is afterwards alone. And that is incorrect. We want to negate everything that we just created. So in this case, we're going to have this 2x cubed minus the 2x cubed. That should always go away. And we have a 0x squared minus an 8x squared. So this becomes a negative 8x squared. And just like for regular long division, we're going to bring down just the next part. Just the next part. We don't bring down everything, just the next part. And we're going to have that as a plus 6x. Now we're going to repeat everything. So what do we multiply this x by to get us a negative 8x squared? Well, it's going to be a negative 8x. And we're going to put it right over here. So when we multiply this negative 8x times this x, we should get a negative 8x squared. That's why we chose this. And we're going to continue multiplying this by everything after the x. So a negative 8x times this positive 4 gives us a negative 32x. And we have to negate everything. So this is going to be positive now, and that's positive. Now we combine them. This cancels out. And what do you get when you do a 6x plus 32x? We're going to get a positive 38x. Then we carry this all the way down, plus 152. And then we're going to do the same exact thing. Starting with our x, we look at that and see what do we have to multiply this x by to get a positive 38x? Well, that's going to be a positive 38. And we multiply this 38 by this x, we're going to get that positive 38x. And we're going to keep going. We have that 38 times this 4, so what's that going to be? That's going to be 152. So now we negate everything. So this is going to become a negative, and this also becomes negative. Remember, negate everything. That cancels out, and we have 0 left. So this example has no remainder. There's no remainder. That means that x plus 4 is a factor of 2x cubed plus 6x plus 152. So in this case, the answer is just going to be whatever's in the quotient. We don't do anything else to it. You can just rewrite this as 2x squared minus 8x plus 38. That's your answer. Let's jump into our second example to see how we would write this if there was a remainder. In our last example for today, we have x squared minus 7x minus 11, and we're dividing it by x minus 8. And we're going to do polynomial long division. But remember, this example is going to have a remainder. So we got to figure out when we need to stop. But first, let us set this up in our polynomial long division fashion. We're going to take our divisor, put it up front. So we have an x minus 8. We put our little house here. We have x squared minus 7x minus 11. And notice that we're not missing anything, so we don't have any placeholders. Next, we're going to focus on our x. Once again, whatever's in front, this may not be x. It might be something more. But in this case, it's an x. We're going to start there, and we're going to look at this first value and see what do we multiply this x by in order to get that first value. Well, that's an x squared, so multiplying x times that x is going to give us this first value. So we have an x squared, and then we keep going. X times this negative 8 is going to give us a negative 8x, right? Then we're going to negate everything. Negate it all. So that first one becomes negative. The second one becomes positive. Then we combine. That goes away. This gives us a positive x. And then we bring this down. So this is a negative 11. Now we look at this x again, and we're going to see what do we multiply this x by to get this x here. Well, that's just going to be a 1. And it's going to be a positive 1. So we multiply 1 times x, gives us that x. And 1 times this negative 8 gives us a negative 8. And we negate everything. So it becomes negative, that becomes positive, that goes away, but this doesn't. this is going to give us a -3. We have nothing to bring down. Now there is a case in regular long division where you can kind of just bring down zeros when you're doing decimals. But in those cases, you don't really have a remainder. You just kind of stop however many decimal places that you need. But if you're doing remainders, you stop when your number can no longer go into that bottom number. The same thing is going to be true for polynomial long division. Remember, this x controls everything. Since x can't go into a constant, we have to stop here. As long as you have a power of x that this can go into, you keep going. But the moment you don't have a power of x that this can go into anymore, you have to stop. The rest of it is a remainder, and you will write it like this. So you have your answer is going to be x plus 1, and then you're going to either add or subtract whatever that sign is, in this case subtract, that remainder value over the divisor. So it becomes x plus 1 minus 3 over x minus 8. If this was a positive 3, you'd be adding 3 over x minus 8. But because the sign is negative, you're going to subtract it. So our answer for this is going to be x plus 1 minus 3 over x minus 8. This is how you're going to write your answer when you have a remainder left. This also shows us that x minus 8 is not a factor of x squared minus 7x minus 11. So I hope you were able to follow along with today's examples, and I hope you now know how you can handle your polynomial long division. However, if you have any questions about what we saw today, or even on homework, you can always put in the comment box below, or visit my Facebook page at Tutor Me Sempai and tell me all about it there. If you haven't done so already, remember to leave that like. It really helps the channel by letting YouTube know that you found the video helpful. And if you found the video helpful, so can someone else. So leave a like, hit the notification bell, smash the subscribe button, and share this video with a friend. Well, that's all the time I have for today. I'm really hoping this helped with your homework, and I'm hoping to see you again next week. I'm Courtney, this is your playlist, and this has been another session of Tutor Me Sempai.